Hello, welcome to another Raise3D live stream. I'm here in the demo studio. I'm joined by Emma Coury from BASF Forward AM. We're here to talk about their materials, the partnership we have going on with them, dating back for the Open Filament program, getting some new materials into the OFP, things we're looking forward to working with both companies in the future. So Emma, thank you very much for joining us. Welcome to the stream.
Hi, Nick. Thanks for having me. We are excited to be here with Raise3D. And I guess first to introduce BASF Forward AM and why I'm here. So BASF Forward AM is a subsidiary of BASF New Business, and we are a 3D printing startup within BASF as a big company. So what's really nice is that we have a smaller team and we are a true startup, but we also have the backing and the access to the resources of BASF globally. So that's always really nice. And for us, we are machine agnostic and we are material manufacturers, and we make filament materials, powder bed fusion, and we also focus on photopolymers. So we have across the entire 3D printing industry, but here today, you're going to focus on our filament materials. That is what I work with, and also how we work with Raise.
Yeah, awesome. So getting into those kind of filament materials, can you give me a little bit more detail on the current catalog of materials that you guys have? Like what's the kind of start to finish, PLA to engineering grade materials? What's the layout look like?
Yeah, absolutely. So for us, we have a wide range of materials. We have our standard filaments, which would be, your PLA and ABS. And then what we really focus on and put a lot of emphasis on is our engineering grade filaments. So we have, different reinforced filaments as well. That is another big part of our portfolio. So we have carbon fiber and glass-filled materials as well. We have PHT carbon fiber, PET carbon fiber, more of those as well. We also offer support filaments. We have a BVOH and a HIP support. BVOH is our water-soluble support, which is very easy to work with. HIPs are more breakaway support material. It can be dissolved, but uses a bit harsher chemical process. And then we also have metal filaments and flexible filaments as well, when those are more of our unique to us filament categories. For the flexible filaments, we actually use BASF raw materials to make those filaments instead of having to outsource that or anything like that. So very exciting new addition to the product portfolio.
Yeah, it's very, very cool. So you guys make all of the materials essentially in-house. You guys mentioned you're a filament manufacturer, so everything comes directly from you guys, essentially on what you're working on.
Yes, exactly. So we have our production in Emmen in the Netherlands, and then we ship globally.
Nice, fantastic. And then since you brought it up, working with like the BVOH materials and the more experimental engineering grade materials, it's really why I like to highlight the partnership that we have with you guys, because your materials are really, really good. And because we work kind of directly, we're able to optimize the open filament profiles and then get people the best settings, so you don't have to be fine tuning with a lot of these, like carbon fiber nylons. They can be pretty hard to work with. A lot of the fine tuning is done kind of by both of us, and then it gets people off on the ground running with new materials. I'm just looking at some of the things that I have here with the BVOH material. These are done in the BASF PAHT carbon fiber, PAHT CF15. Here I have just a smaller test print done with directly off the E2. It's got the tower here and all the raft, but all of this is done in the BVOH support. And I've had the chance to dissolve this one out. So that's the actual kind of final part that looks really, really good on all the internal details. And I haven't had a chance to dissolve this one later. We'll probably get pictures of this up on our social medias. But that is unique. If you can hand me the brain gear.
Yeah,
the other one to the left. Yeah, all the way on the
you can
left.
see with the BVOH, it's nice for any hollow structures or fine details when it dissolves, that you don't have to find a way to get in there and break the support away.
Yeah, so I have one of these, something similar to this printed out of PLA, and this is going to be essentially the final result. This one's just a quarter of this. So still really complex print, but it did beautifully with the PHTCF and the BVOH on there. So that should dissolve no problem just like I did with this test piece here. So very, very good materials. And then looking forward.
Great. Oh, go ahead.
Yeah, of course. No, I was just thinking of going a bit more into kind of the partnership between Raise and then BASF Forward AM. What's that partnership kind of been like? I mean, are you working with our machines kind of on your own end? What's the whole process like?
Yeah, so for us at BASF, we are machine agnostic, but here in the current lab that I'm sitting in, we have two Raise printers. We have the Pro 2 and the Pro 2 Plus. And when we have projects that we work on for customers, demonstrator parts, or new filaments that we want to test, we work on Raise printers. And when we have issues, we go to people like Nick and they help us work on the printer. And when they have questions about our materials, that's where we come in and can support them and their customers. Exactly.
Running, and then we're of course working on your guys' material, so we want to get your input on the best way to print those. And then all kind of comes through again in final products of what our customers are seeing when they start working with these as well. So one thing that I've seen with the E2, I found that one does print flexible materials very, very well, better and cleaner than the Pro 2s in my opinion. And you mentioned that you're also working on some of the elastic materials. Can you go a little bit more in detail into the flexible filaments that are coming out, what you guys are working on?
Yeah, absolutely. So we actually just launched 3 new flexible materials, and they are the UltraFuse TPU64D, TPU95A, and TPS90A. And so all of those can print really, really nicely on the Raise printers. Unfortunately, I do not have an E2, so I don't have the comparison, but they do print nicely on the Pro 2 as well. And part of this is because the Raise printers are direct drive printers, and those work really nicely with our flexible materials. And so for the 3 different flexible materials, the numbers and letters, so the 64D corresponds to the hardness of the material. And so we have a different range of hardnesses, so for different end applications based on what your needs are.
And then you mentioned the 3 different hardnesses for those materials. Can you kind of break that down a little bit more in terms of what's more flexible, versus a D to an A?
Yes, so it can be kind of confusing because there's some overlap on those 2 different A and D scales, but then in general, the higher the number, the harder the material will be. And then also in general, anything on the D scale will be harder than anything on the A scale. So 90A is your softest, 95A a little bit harder, and then 64D is the hardest.
Yeah, so going basically up in the grade, the lower the letter, essentially. But
yes, exactly.
Yeah, so there's a variety of flexible materials that you kind of have to choose from. And then again, we're going into like the 90A softness. So you have a wide variety of things for that. Getting into, you mentioned some of the more engineering grade materials I have here, some of the PAHT. What are the other things that you can look at? I know we mentioned the PET carbon fiber. Are there any new engineering materials that you're looking at? Kind of what's the current space for those grades?
Yeah, so for us, we some of them that are exciting is that we'll be soon launching some glass filled materials as well. And we do have one polypropylene glass filled, and we are actually working on having that certified in the Open Filament program. So that should be hopefully coming soon. And some other engineering grade materials that we have already in the Raise Open Filament program are our PLA Pro 1, which is just a better version of our PLA is really overall what it is, but it's tougher, it prints nicer, and yeah, much easier to work with. We also have our ABS Fusion Plus, which is again an enhanced version of our standard ABS. Again, easier to print with, easier to work with, because ABS can sometimes be a more difficult material to print. And then we also, in the Open Filament program, have our polypropylene and PET materials as well as our PET carbon fiber.
So getting into the polypropylene or the carbon fibers, is like the engineering materials that you guys are working on are already getting included in the Open Filament program. So Raise3D is just kind of working on keeping pace with whatever you guys are putting out, making sure that our customers can use it essentially pretty much as soon as it's released, but still cutting it pretty close. I know we take a little bit more testing, but we are basically trying to keep up with you guys as much as we can on releasing materials and making sure that people have the templates for them.
Yeah, and I think that really enhances our partnership. It's not we release material, then we talk to you guys. It's as we work on materials, we are really always talking with you and working with you to how do we best offer the best solution for our customers so that when the material's ready, we have printer solutions as well.
Mm-hmm. Yeah. Sorry, I was just looking at. We did get a question asking, does the final printed product print objects smooth without lines? What's your take on kind of the surface finish and layer lines of your materials?
So that's really going to depend on your printer settings overall. With a lower layer height, you're going to see less lines and have a much smoother finish. It will also depend on the material. Some materials require a slightly, or can have a lower layer height. Others need a slightly higher layer height, just depending. Potentially a filled material might need that, but yeah, there's also, depending on what your requirements are, post-processing options as well. But it will depend on how you print it and your print settings and everything like that.
Yeah, there's if you did want more information, just speaking to the audience, on post-processing, we did a couple streams earlier going through the processes on how to finish parts, remove layer lines, different printing techniques, and even different materials. Like we mentioned, the types of materials that you're working with, some will hide layer lines better than others. I find that carbon fiber filaments and carbon fiber nylons in particular end up with more of a kind of textured surface finish, and that texturing helps hide those layer lines as well. So they do print out very smoothly, but a lot of the surface finish is going to be dependent on the settings you're printing with and then the layer height that you're running at from the get-go.
Yeah, so print dependent, material dependent, but yeah, it is definitely possible to hide those layer lines.
So let's see, and then I did want to get into a little bit of kind of the last material that we're going through. We mentioned the engineering grade materials, still the polymer plastics, starting with like the PLA all the way up to the higher grade stuff. What are some of the other specialty filaments? We went a little bit into flexibles, but you do have one other category of a very, very special filament that we haven't talked about yet.
Yeah, so another category that Nick is referring to is our metal filaments. So we actually have two different metal filament products, our UltraFuse 316L and 174pH. And I know a lot of people think it sounds crazy, but yes, we are printing metal filaments. So it's a metal filament, it has a polymer filler, and it does have to go through post-processing to remove this polymer filler. It goes through catalytic debinding to remove the filler, and then you sinter your metal part together, and what you are left with is a fully metal part, and it is a stainless steel part. And so it's you could work with this part just like you would any other. You could do machining, any post-processing that you would normally do with a metal, you can do with these. You could weld them, whatever you want. So very customizable.
A lot of kind of what we're looking at. What are the kind of settings and compatibility for that material? What exactly does it print at?
Yeah, so those print at a bit higher temperatures, but typically you're looking at like maybe 240 to 250 degrees Celsius for an extrusion temperature. You want your bed temp to be above 100 C. And so again, these materials aren't built for one specific printer. If your printer has hits the specs that are required, you will be able to print our metal filaments.
It really is a matter of just this material is still pretty much ready to go for a lot of machines. The most important thing about it, though, is the post-processing kind of process that it goes through to convert it from that metal filament polymer kind of composite into purely metal parts. So currently, what's that process look like? The parts have to be shipped out to a certain location to have that process done, and then they're usually shipped back, right?
Yes, exactly. So right now we work closely with our partner in New Jersey, DSH Technologies, and we work very closely with them. They work with our end customers, our machine partners as well, and they make the process very simple. You fill out a form, you ship the parts to them with the form. They take care of all the debinding and sintering, and then send you your finished part back. So overall, very easy and smooth process.
Oh, we did get another question. asking what spool sizes do you offer for all the different materials? And since we're on the metal fill, that's a good one because I know it does come in a different specification.
So for the metal filaments, because those are a bit heavier, those are in 3 kilogram spools. Our other materials, typically we sell them in 750-gram spools, but you can get larger sizes as well, depending on the need.
Do you guys go up to 3 and 5, or kind of what's the maximum?
We have some very large spool. I know we can go up to 8.5 kgs, but that's not for every single material.
Of course, that makes sense. So what would be, you guys have a website that people could look up the filaments and get more information on? I believe we can link that up as well.
Yes, so our website is forward-am.com, and that will have links to all of our filament products. You can see all the different spool sizes, different colors. Yeah, you'll be able to find any information there.
Yeah, so definitely want to go check that out, see the full selection of the materials that we're all talking about here. But yeah, so thank you very much for that question. I wanted to get back into the metal films. That's what we were talking about before. So the post-processing, shipping the parts off once you get them back. And then, like you said, it's essentially, you can finish them just like any other, machined metal pieces. They polish really well. For the differences between the 316L and the 17.4 pH, what are the differences between the properties of those two specific types of metal filaments?
Yeah, so for they're both stainless steel metal, and so when you're looking at them, it can often be hard to tell which part is which. But one trick that I like to use and share with all of our customers is that the 17.4 pH is magnetic. So if you have a part and you don't know which it is, stick a magnet to it and you will find out. So that is one key difference. In addition, the 17.4 pH has a bit better mechanical properties. It has higher tensile strength and modulus as well. But both can be used for tool jigs and fixtures and tooling, spare parts. Yeah, we've seen a wide variety of applications from our customers.
Yeah. And then I wanted to know, someone asked, how long does the debinding and sintering process take? Do you know the actual length for once the part on the part side versus the shipping side? Because I know there's a big time difference in shipping as well.
Yeah, so for us, BASF has 2 debinding and sintering runs per month. And so we know exactly when they will be and when customers need to get their parts in by. And then the following week, they will go through debinding and sintering, and then the parts will get shipped back. So it's really set days that we go through debinding and sintering right now. But we're very open with that schedule, and so you can kind of time out your shipping and parts and everything like that. But the runs are done in a single day.
Okay, yeah. So basically within a day to debind and sinter the parts. But the whole timing of whenever you're working on a part and going through the processing tickets, that kind of timing of when the parts are sintered does need to be factored in.
Yes, exactly.
Yeah, a bit more on that. But yeah, so I think we are probably good to just do a couple more questions just within the stream. But kind of want to get your opinion directly. Like, what's your favorite material that you've been working with?
Ooh, my favorite material. I mean, the metal filaments are definitely really exciting to work with. I probably like working with those the most, I would say. They're also nice because you can, even before you send them for debinding and sintering, let's say there was a small defect on part of it, you can actually like sand that away or make the part look exactly how you want it to look before it becomes the final part. So that is always really nice, having that extra bit of control. It's also been nice printing with our flexible filaments, just very different than a lot of other materials out there. So
yeah, getting to work with all the unique properties, I think, is something really, really special in kind of the material experimentation. And that is something else that I have done, but kind of just slipped my mind, is being able to modify the parts where they're still in that green state, they're still that polymer mixture. It's a lot easier to, like you said, sand them or kind of modify just that part before sending it off to metal and then working with it after that. So you kind of have like a middle stage you're able to adjust them in, which is really, really interesting.
Yeah, it definitely takes a bit more of and art as well, because you can really get your part looking exactly how you want it.
Exactly. Couple more questions. Can you debind and sinter parts in a ceramic kiln? Is there any kind of home process for this yet?
No. So for us, the way our parts go through, they use actually nitric acid to go through catalytic debinding, and that is a chemical that you should not be using at your home. It should be in a very dedicated debinding and sintering process. And if other materials or anything actually get involved in this chemical process, it can be very hazardous. So no, you are going to want to do this in a dedicated space.
So that's where it really comes in, and why these parts need to be sent away. There isn't any kind of home or office solution yet. It's really important to make sure that there's not any kind of any foreign material in those. It's the brown part is the after the debinding stage. Is that correct? Okay, yeah.
Correct. Yes.
Yeah. So once in the brown part stage, you don't want any kind of contaminants or anything else. And it's that debinding process to remove the polymer. You can't just sinter the printed part already. They do need to go through that chemical process in order to be sintered, and that's really what cannot be done in a home or office environment. So the parts are already being shipped out to be debound. They're just being sintered kind of at that same time and then shipped back already. So I don't know specifically when or if there would be some kind of home solution for it yet. But I know as metal 3D printing is becoming kind of more popular, more available, more applicable, I believe we should be seeing some kind of solutions coming out in the future for sure.
Yes, definitely.
And then, yeah, just something else was asking again about the home kind of debinding and sintering option. But again, we're just kind of all waiting for that to be available from somebody.
Yeah, for sure. We get that question a lot because people want to, you've printed this nice, beautiful part that you've worked really hard on, and people want to be able to do it at home, make it easier. But yeah, that is not currently available. But I can also promise you, the current solution we have, people understand that these are, parts that need to be taken great care of. It's not just throw it in the furnace and we're done with it. No, it is, working with our partners who take great care of everything and are always looking out for our customers' best interest.
Yeah. So where can people get more information on the metal fill filament specifically? I know there's a lot of other caveats that come with printing that material, so I would highly recommend putting a lot of research in before starting with it. Where would that information be readily available?
So that will also be on our website. We have our metal filaments. We also have metal filament user guidelines, which are basically tips to help you successfully print a part, but also successfully go through debinding and sintering. And those are a great place to get started.
Yeah, absolutely. Just keeping in mind of the whole process, start to finish from the beginning of the project is definitely going to help out a lot.
Absolutely. And that's also what I'm here for, is when customers have questions on how to go through this process, if their part will survive debinding and sintering, they come directly to us as well. And so
so you do get that feedback on once a part has been printed, how likely it is to go through sintering. Do you guys do kind of recommendations on parts beforehand, or only on parts once they're received?
Yeah, so yeah, part of my job is, if I actually had a question just yesterday, someone asking if their part would be good to print with metal filament. They hadn't printed it yet, so they could ask us ahead of time. And we gave recommendations on if it would survive debinding and sintering, or what tips or tricks we could do so that it would successfully debind and sinter into looking like the exact part they want it to and not get deformed in any way. So yeah, we can offer that ahead of time. And we also offer simulation services if you have a very complex part. Yeah, we can have our team in Europe do simulation to see how it will change and deform it in debinding and sintering, and kind of, again, how to fix that as well. So you get the exact part you're looking for.
Yeah, so you have even more resources available than just the written material. They're there to help and look and make sure that things are going to come out as needed for, again, this kind of really experimental process. But again, go to the experts. They know what they're talking about. They can help you. So you have that main website there. And then again, for anything else that we're going to be doing here, continuing up the partnership with BASF Forward AM, keeping eyes on the Open Filament program. Our website is available as well. And then if you are working with any of their materials on our machines, you're always free to come to us, and then we can help support and work with anything on the Pro 2s. But I think that is going to do it for the stream today. Thank you very much for joining me, Emma. Is there any kind of closing notes, anything else you wanted to push for the very end?
Yeah, just thanks for having me, Nick. And as always, it's great working with you guys, and we can help our customers together, whether they come to you or us. So it's really a great partnership. So thank you.
Yeah, of course. Looking forward to keeping it up. I want to thank everybody else for tuning in to the stream today, and we will see you next week.